Okay, good morning. So, if you remember, we had one problem left from the previous session. Let us see. I can find it here. If you have it, you can start thinking about it, and then we can discuss about it together. So let me see if I'm writing it correctly. So L is x is equal to 3. Can you read it for me? My eyes doesn't see this. So do you have it?
3t minus 1.
Yes.
Y is minus 2t minus 3. And then minus t plus 2.
Minus t plus 2.
Yeah.
This was L, and I told you, do you remember, I wrote first L prime with t again, but we discussed that if we have two lines in the same problem, it's better to start the next one with t prime. So can you read it for me?
2t prime plus 2.
2t prime plus 2.
3t prime minus 1.
Yes.
And then minus 5t prime plus 1.
Yes, thank you. So yes, I think it would be a good idea if you start thinking about it yourself now. 5 minutes, and then I will start talking about and we continue the lesson. So there are many, many interesting problems that we can combine when it comes to lines. So was the problem clear? We want to understand the relative position of these two. Okay, what happened? Did you get the position of these two? Okay, I can wait more. Okay, what happened? Is it so hard? Okay, so let us see what is going on. So what we are supposed to do first, if you remember, of course, we start reading dl, the direction vector of the first line, which is 3, minus 2, and minus 1. And then I consider dl prime, the direction vector of the second line, 2, 3, and minus 5. So are these two parallel? None of them is a multiple of the other one. So you see that dl is not parallel to dl prime. So this means that I have two possibilities. Either L and L prime intersect, or L and L prime are skew parallel. Yes? So what is your opinion now? At least tell me what I'm supposed to do. Because we talked about intersection just yesterday. So we want to see, because I have two possibilities, I check if they intersect or not. If they intersect, so I am done. If they don't intersect, they have to be skew parallel. So skew parallelness is not something that we check directly. We rule out the other possibilities, and then what is left is skew parallel. Yeah, is that clear? So okay, so we go for intersection. But the lines that I told you yesterday was canonical form. These are parametric form. But of course, at the end, there is no difference. I told you how can you get rid of parametric form in favor of canonical form. So you should be able, these things, they are standard things. You should go back and forth easily between parametric form and canonical form. Yes? So at the worst case scenario, we could change this to canonical form and solve the problem as we did before. But that is a little bit of extra algebra, probably is not necessary. So the point is that when you want to solve the problem, you want to find the intersection, what you are supposed to do, you need to consider this line and that line in single system, yes? So the first one is the equation of the first line, but of course the equation of the first line consists of three equations itself. So you write x is equal to 3t minus 1. So this is interpretation is important. Yes? And this is the equations of the first line, and x equals to 2t prime plus 2, y is 3t prime minus 1, and z is minus 5t prime plus 1. Yes? I don't think you couldn't write this, because that is the general strategy. Whenever we want to find intersection of any two objects that we have their equations, we set up a system and put the equations in that system and try to solve it simultaneously. But of course, you need to have a good understanding what is going on. When I want to solve a system, immediately I start counting the number of unknowns. So x, y, and z, t and t prime. These are the unknowns that you see in this system. So it is 5. But how many equations I have? 6. I told you yesterday, you shouldn't be so happy. You don't think that I have more information, yes? But how many of them in principle is needed to determine everything? 5 of them, because I have only 5. I use 5 of them, and when I find the answer, I check the last one, if that's working or not. Yes? But even this is easier than before, because, for example, now this is completely algebra, not related to geometry at all. We want to investigate a system of equations. This is more or less a Math 1C problem, but with more number of variables. So what do you think? What is the best way to do it? Probably that is, I don't know how many of you came up to this point. Yes, if you came up to this point and you couldn't draw any conclusion, it means that your algebra was a little bit confused or shaky at that point. But this is not something that, so at this level you need to understand, I want to find the intersection between two objects, I know the equation, so I set up a system and put the equations there and try to solve it simultaneously. Yes? But then I have a little bit technical problem. So what is the best way? I don't know if there is a best way. What is the best way to solve it? To understand at least this system. For me, I see that x is here, x is also here. I equate them, I get a relation between t and t prime. But t and t prime are two unknowns, I have one relation. I need one more relation, then I can equate y and y. Then I get another relation between t and t prime. So I have two relations between t and t prime, and t prime are two unknowns, so in principle I should be able to find t and t prime. And when I have t and t prime, the problem becomes much simpler, yes? So let us just do that, yeah? So what I do, I would say that, okay, this is x, that is also x, so I put them equal, so this means that 3t minus 1 is 2t prime. So you shouldn't get lost, this is always the case, this is the skill that you need to develop. Sometimes there are many information going on, you need to train yourself to be able to understand the core of that, so those don't get lost, yes? So this is the case. And then I would write the y's. Of course, you could have chosen t's. It doesn't matter. Might be t. Even z's are better because okay. Let us just do it. So y is minus 2t minus 3 equals to this y is 3t prime minus 1. And then this is now under control, yes, because that's the two equations, two unknowns in principle. Everyone should know how to solve it. So what I do, for example, if you want, I can make it a standard. I can move this to the other side. I don't know, any trick that you know how to solve it. So we don't need to reorganize it because now, for example, I want to get rid of t prime. What do? I multiply the first one by 3 and I multiply the second one by minus 2 because then the coefficients become the same. When I add them up, that t prime is gone. Yes? So this becomes 9t minus 3 is 6t prime plus 6, and then I multiply this by minus 2, it becomes 4t plus 6 is negative 6t prime plus 2. And when I add them, this becomes 13t plus 3. The right hand side, this one and that one are cancelled, it becomes 8. So t becomes 5 over 13. And then I choose one of them, I don't know which was, for example, here, and then I can calculate t prime. So if I put t here and multiply it by minus 2, it becomes minus 10 over 13. And then I have minus 3 is equal to 3t prime minus 1. So this means that 3t prime is equal to, I move this minus 1 to the other side. So it becomes negative 2, negative 36 over 13. I'm looking for t prime, so I divide by 3. It's negative 12 over 13. Yes. I hope that I haven't done something wrong. So I move this to this minus 2 and then minus, yes, that's correct. Okay, but this is not done yet. Of course, I expected even from the beginning that I would get two values for t and t prime because I have two equations and two unknowns. In principle, I should get the answer. But can I at this point say that they are intersecting each other? No, because there is some more constraints to be satisfied. So it means that, so how can I check if they are intersecting or not? Now you have your t and t prime. So what should I do?
Put them back into x and y and so.
No, x and y is not necessary. Because I used equality of x's and I used equality of y's and got these answers. It is clear if you put them back, you will get the same answer. But what is not clear is the ones that I haven't used so far, and these are z's, yes? So I put t here to calculate c, and I put t prime here to calculate c. If these z's are also the same, then they are intersecting. If they are not the same, then they have to be skew parallel. Yes? So let us check. The first z is minus t plus 2. I got t to be this, so it's minus 15 over 13, 5 over 13 plus 2. So it becomes 21 over 13. And the other z is what? Minus 5t prime plus 1. I multiply this by minus 5, it becomes 60 over 13 plus y. So this becomes 73 over 13. So they are not equal. Yes? So you see the calculation was also not heavy. Yes? So you might get lost. You need to take experience from these why you couldn't solve this problem. You need to teach yourself why I couldn't solve this problem. So is that clear? Okay. If you don't mind, let me see if we can also... okay, so we go to GeoGebra here. I choose the 3D graphics. Okay, and I discovered this is the syntax, so I would appreciate if you can read it for me. So you just start with curve, yes, and then you choose this one, expression, parameter variable, start value, end value. Okay, so I press this one. Okay, so can you just read the first equation in the first line?
3t minus 1.
3t minus 1.
Minus 2t minus 3.
Minus 2t minus 3.
Minus t plus 2.
Minus t plus 2. And of course I have to introduce what is my parameter. And then of course the parameter in this problem is t. And the point is that you have to give a start value and an end value. But of course we know that the line should go forever. I don't know, we can choose randomly something. If it doesn't work, we change it, okay? So it's minus, I would say that let us make it minus 10, and then let us make it 10. If that was, okay, now you have already the line. So this is your line, if you see. Okay, so let me just see that this red is the x-axis, the green is the y-axis, and the blue is the z-axis. Okay? How did I understand that the red is the x-axis? Not, because I don't know why it's not labeled. Probably I can ask GeoGebra to label it. But how do you know that I understood that x is the red axis? And
Because
why?
The right hand rule.
Yeah, this should be the right angle rule, yes? So if I take this green one to be y, and this red one to be, if I take the green one to be x and the red one to be y, then according to the right hand rule, the z direction should be opposite. Yes? So if I want to work with a right-handed rule, with a right-handed coordinate system, the red one should be x, the green one should be y, and then this one is z. Okay? Okay, and then I would appreciate if you can also read the second one for me. So if curve, I go to this one. Okay, can you read it?
2t prime t, or
We don't need to, yeah, we can of course introduce t prime, but it doesn't matter. We can just read
yes, 2t plus 2.
2t plus 2, and then I go to the next one.
3t minus 1.
3t minus 1.
Minus 5t plus 1.
Minus 5t plus 1. And as before, the parameter is t, and I will take the same start value minus 10, and I will take this one. Oops. Are they intersecting or not? Because we realize they shouldn't intersect. Yeah. We shouldn't be worried because we have to trust mathematics. Yes. So they are not intersecting, actually they are skew parallel. Yes, do you see that? They are not parallel because they don't lie on the same line. But from this perspective it seems that they are intersecting. But they are not, yes? So they are really skew parallel. So what we predicted was correct. And I think GeoGebra is also a great tool if you want to discover a little bit more about these things. Yes, is that understandable? Okay, thank you. We go back to our lesson. One thing I want to talk about is also interesting. So, I don't know how to start this, so let me just put this back. Okay. Okay, let me ask you one question. Okay, I write this 2y plus 3z is equal to minus 2, and I put this curly brackets here, and I write x plus 2y and plus 3z plus 2 is equal to 0. Okay. I would say that there, I want you to tell me which one. You need to choose one of these words. Something. Which one do you choose? I want to say something about this. The line, the plane, this, blah, 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 okay? So, which word do you choose? Because if I ask you what is this, by the way, what is this one in 3 dimensions? It's a plane. So what is this one?
Plane.
Plane. So what do you choose, line or plane? Yes?
Line.
Why?
Because it's the intersection of the plane.
Yeah. So that is common, yes? When you write this in mathematics, it means that you are interested on the points. You are interested in the points that lies on this object and that object simultaneously. But you told me that this is a plane that's also a plane. Either this set is totally empty, if they are parallel, or if they are not going to be empty, they are no longer a plane. They have to be the intersection of two planes, which becomes a line. Yes? So sometimes that is also very common. Don't get confused. That people write the line. Okay, so now I want to ask you, so by the way, how do you feel about this? So it means that this, I have a plane, I don't know how to draw it, but this is your plane somewhere, for example. This is the first one. And then you have another plane. And then where they intersect is this line, you know? It's a strange way of addressing a line, yes? But that is what it is. So it means that this is one of these planes, that is another plane. So, and then I have the intersection of these two planes, which is this line. So these total equation is not this one, is not that one, is just the intersection, which is a line, yes? But then something suddenly happens immediately clear from this picture. In how many ways I can express this line as intersection of two planes? Because these are one pair of planes that gives me this. Are there other possibilities or not? Actually, there are infinitely many possibilities, yes? Because, for example, if I have this, it's like the papers of in a book, yes? So I don't know, this plane is different from that plane, this plane is different from that plane. But if I put the equation of this green plane here, the equation of this green plane here, again I will get the same line. Is that understandable? And then they are totally different. So it means that when it comes to lines, it is not very easy by just looking at the equation, recognize that you are expressing the same line. You have to do some calculations, yes? So now we want to talk about this. So I give you two lines in this form, and then I ask you the same question. What is the relative position of these two with respect to each other, okay? So this is one of the lines, so I can now safely, you understand, I can safely call it L, okay? And I give you another one, L prime, exactly in this form. But I can combine them, one of them in this form, one of them in canonical form, one of them in this form. But that is not hard, yes? Yes.
So if the planes lie on each other, I mean they intersected all, wouldn't that give a plane?
Yes, that's what I'm saying. Yeah, if they are parallel or on top of each other, this is not a line.
Yeah, okay.
But I can immediately check that the normal vector is, and this is different, so the normal vectors are not parallel.
Okay.
So
So
the
you need to
line,
check
yeah,
first.
yeah, of course. I mean, that's not up to you, because when they write the only thing that I want to make sure that you understand, don't get surprised when you say the line, yes? When they say the line, it means that they have already checked, otherwise that's a mistake, yes? So, okay, so this is one of them, and the other one is this one. X plus 2y equals to 0, and x minus 3z is equal to 2. So now you understand what it means. It means that these two are two of the planes, two of infinitely many planes that intersect at this line. And these are two of infinitely many planes that intersect at this line. Now, this is a line at the end, and that's a line at the end, yeah? But then I want to understand what is the relative position between these two lines now, expressed in this form. So the geometry is the same, the algebra becomes different. Okay, so I want to wait for you to see how you think. The picture that I drew here and erased that is probably helpful. Yes? Any progress? Yeah, I hope that you haven't changed this strategy, yes? So what was the first step if you want to understand the relative positions of two lines? In all previous cases, what we did first? Yes.
Find if they're parallel.
So by
The
finding
lines.
the direction vectors.
Yeah.
Yes. In the canonical form and a parametric form, it was more or less instantly visible. Just you pick up the numbers. So, but still, we need the direction vector. But the direction vector of this is not just easily seen that you can pick numbers from the equations. You have to do something to be able to find the direction vector. But it's still the strategy is the same. The first step, you shouldn't get lost. You need to think, I want to find the direction vector of this line. So do you have any idea what to do? Yes?
My guess was finding the normal vectors of those two planes and then cross product.
That's exactly clear, isn't it? So if I can show you here by this paper. So for example, assume that this is one plane and that is another plane and this is the intersection one. So what Denise is actually mentioning is that this has a normal vector. This also has a normal vector. And it is clear when I cross product them, it becomes a vector perpendicular to these normal vectors. But then automatically it becomes parallel to the line that I am interested in. So if you have now, you can have it as a rule of thumb. If you have these type of lines, you find normal vectors of individual planes and cross product them. So you have to do once here and once there. So that becomes the same problem again. So the only problem, new thing in this problem is that how to find dl and dl prime. Okay, so what I'm trying to teach you is don't change your strategy unless you really know the previous strategy for some reason doesn't work. So you remember the algorithm was somehow find dl and dl prime. So the first thing that you need to think is that how can I find dl of this equation? I don't know how many of you thought in this way. Did you?
Yes.
Yeah.
Okay, so that's good. Because that is a very important step. You shouldn't change the strategy unless that strategy is useless. We have to throw it away and find another one. Okay, so let us just do the calculation quickly, and I want to complete this lesson so that we can continue to the next level. So here I will take, I don't know how to call them, so let me write n L and then n prime L. Yes? So what can I write for NL is 0. I need to read the coefficients, but the coefficient of x is absent, 2 and 3. And NL prime is 1, 2 and 3. So this means that DL that I am looking is just a cross product of these two vectors. I intentionally wrote them beneath each other, so this becomes 6 minus 6 is 0. The middle one has an extra minus sign, 0 minus 3, so it becomes positive 3. And the last one becomes 0 minus 2. Yes? In your calculation, either you have got this exactly or the opposite sign. Minus 3 plus 2 is also possible if you have reversed the order. Yes, and if I am doing some mistakes, please let me know. Now I go to the next one. I have NL prime. What is NL prime? It is 1, 2, and 0, the coefficients of x, y, and z. And then I have n prime of L prime. So it is 1, 0, and minus 3. 1, 0, and minus 3. And then I cross product them, so let me write cross product. Then I get dl prime. It's equal to, let us just cover this, it's minus 6. The middle one has an extra minus sign, it's minus 3. And I have another minus, so it becomes positive 3. And then finally I have, have I made a mistake or not? Because the one that I have written here, it seems that they are, okay. So minus 6, so it's minus 6, 0, and then it is minus 3 plus 3, and then that is 0 minus 2. I don't know, can you confirm my calculation here or not?
That's what I got as well.
That's what you got?
Yeah.
Okay. Okay, so are they parallel? No, they are not parallel. So this means that DL is not parallel to DL prime. So this means that I have two options. What are the options? L and L intersects L prime. L and L prime are skew parallel. Okay, then how should we understand which one is which? Again, I have the same scenario, so you shouldn't be worried in that point. You need to put this equation for this line and that equation of this line in one system. Then again, the same story happens. You will get 4 equations, but you have 3 unknowns. So 3 of them is enough to solve the problem, yes? So I will write them in a system, and then of course this is up to you to do the algebra more efficiently. Okay, so this is x plus 2y plus 3z plus 2 equals to 0. And then x plus 2y is equal to 0. X minus 3z is equal to 2. By the way, this is an algorithm. Might be you say that, okay, why we should go in this way. I put the system first, and if I get an answer, then I am done because that's intersection. But if you don't get an answer, then what will happen? Then it means that this is not intersecting. Then 3 cases are left to consider. Then you have to find DL and DL prime. So that's a more or less a chance which one is which, you know. So if you want, you can start with putting them in a system first rather than finding DL and DL prime. But I mean that you need to understand the geometry behind that yourself, okay? So I don't know, what do you think we should do? What I will do, I don't know, what is the most efficient way do you think we can do it? In my opinion, I can find y in terms of x from this equation. I can find z in terms of x in this equation. That's good. Because when I find y and z in terms of one variable, I can use another equation, then it becomes an equation in one unknown. So that is a good strategy that I have in mind, yes? For example, y becomes minus x over 2, and if I ask you what is z, I move it to the other side, this to the other side, and divide by 3. So z becomes 1/3 of x minus 2/3. Yes? So it's always good. If you can write 2 of them in terms of 1, do it. This is best. I take these 2 and put them in the first equation. Then I will have one unknown left. And that is x. So I will take these 2 and put them in the first equation. So it becomes 2 times y, which is minus x, and 3 times z, which is plus x. By the way, that's also a very interesting thing happening, yes? So this is 3x. Yes, and then I have minus 2. Yes, equals to minus 2. How do you interpret that? I didn't see that these things are going to happen. So I took y and z from here, and I put it here. Then what happens? X that I was looking for is actually completely gone. It's not found. And then what I get is minus 2 is equal to minus 2. But that is always true. So what does it mean? How do we interpret that? What should I do from now on? But because you need to tell me, are they intersecting or are they skew parallel? I did this and I put that in that equation. I get an identity rather than finding my x. Okay, can you tell me what to do next? Yes?
Can x be any value?
Pardon?
Can x be any value?
Not yet. Yes, if I had 3 equations, you are right. X could be any value. But there is another constraint to satisfy. Be careful. You cannot get rid of this. I haven't used this one. It's not just there for just beauty, yes? We have to use it somehow. So what I did, it means that yes, you are right. If I didn't have this one, then x can be any number, and then I have infinitely many solutions for y and z for any choice of x that I make. Yes? But this is extremely important to go up to here and check this one as well. So I will take this one, x, and then 2 times y is minus x. This x is actually very elusive, yes? And then 3 times z is what? Is plus x, again, minus 2, yes? And then plus 2 equals to 0. And make sure that I have done my calculation right. So x is x, 2 times y is minus x, 3 times z is x minus 2. And then I have another 2 at the end. So I have done it right. So this one and that one are gone, so what do I get for x? X is 0. Yes? And when x is 0, so, okay, interpret everything for me now. I did the calculation, interpretation is on you. So are they intersecting or are they skew parallel? And if they are intersecting, can I find the intersection point as well? So what's the interpretation?
If they intersect,
Yes, they intersect. And what is the intersection point?
0, 0, minus 2 or 3.
Yes, that's it. So I have 0, and I put 0 here, y also becomes 0, and I put 0 here, z becomes minus 2/3. And by the way, now the problem is solved. It is not very strange. If you want to confirm, you need to confirm that this point lies on this line. So you check it here and here, it works. If I put y 0, I put this one, this would work. If I put y next 0, I put that, that also works. And if I take this point and put it here, this will work. This also works. Yes, yes. That they are really intersecting, yes? So you might say that, okay, instead of wasting my time for this part, of course, in this case, in principle, if you have started from here, you had your answer, yes? But I mean, that is up to you, which one you to choose to, which one you want to choose first. Okay, is that clear now? So, there is one thing that left. Do you remember we talked about relative positions of planes? We realized how to understand that. We also talked some nice examples about relative positions of two lines. But there is also a relative position of a line and a plane. So how many situations are there if one object is a plane and one object is a line? There are 3 scenarios, yes?
Either they don't intersect, then they're like the line and the plane are parallel.
Parallel. That's called parallel, by the way. Don't hesitate to say parallel. So if I have this plane and every line that you see here that are not intersecting this, it doesn't matter in which direction. There is no skew parallel here in this case. All of them are parallel. So that is one scenario.
Or the line lies on the plane.
Yes, like this. And then otherwise
They intersect.
So there are 3 scenarios. Now how do you think we can recognize that? Okay. So can you cook up a strategy that will work all the time? Of course, in the special cases might be there is a shortcut. For example, in this case, if you have started here, you succeeded to understand what is happening. Yes, but in general, if you have a plane and if you have a line, what is your opinion about how to understand the relative positions of these? Let's say that is much simpler. The hardest one is 2 lines. So how do you think I should act? I have a plane and I have a line. Yes, Ruben?
If the direction vector of the line and the normal of the plane are perpendicular, then they're parallel.
Parallel or
they lie on.
They lie on each other. So because, yeah, that's clear, yes? If I have, this is my plane, and then I have a normal vector, and if this line is supposed to be parallel to it in any way, so the direction vector and the normal vector should be perpendicular, but of course that's also true if the line lies on the plane. So that's good. We find the normal vector of the plane and we find the direction vector of the line, and then how should I understand if they are perpendicular or not? So we dot product them. If it becomes 0, then I would say that, okay, I will find n, normal vector of the plane, and I will find the direction vector of the line, and I dot product them. If this becomes 0, then it means that what? The plane, so if I call it plane P, if I call it line L, then the plane P is parallel to L, or L lies on P. Yes? This is one scenario. And then easier scenario is probably this one, because still there are 2 cases we have to recognize which one is which. If this is not 0, then that is clear. So what can I say? P into L, usually it's better to say L. L intersects L intersects P. And of course, another question is that what is that intersection point? Okay, and how find this? Okay, but how can I realize which one is which in this case?
By taking a point.
Pardon?
By taking a point.
Yes, you take a random point on the line and check it in the equation of the plane. We already know that they are parallel or they lie on each other. If they are supposed to lie on each other, they have to have every point in common. So it doesn't matter if I take a random point. Yes? Because this is already excluded. Is that understandable? Okay, so that's clear. So you can just do that. But might be there is also another algebraic way to do it. Let me see if I have examples here. Okay, so we will continue this next time, and I will tell you how to do another way as well. But there are many interesting problems come after this. Thank you.